Okay, here we go. Lesson 3.6. We're going to be dividing polynomials today. Long division of polynomials. We're going to start out with a couple of simpler things, and it's going to get a little messy towards the end. So lock in, let's do this. The first problem I want to start you with is this one here. Give me a second. So here comes the division part. We're going to divide by, but this time for the first one, we're only going to divide by a monomial, meaning we're just going to divide by it's one hunk of stuff. Later on, we're going to see that we're going to be dividing by, maybe something, maybe instead of 3xy there, maybe it'll be, x plus 4. That changes things up quite a bit. So we're just kind of warming up here for the first problem. And let me see here. I'm going to erase that. There we go. Okay. All right. So whenever we have we have more than one thing in the numerator here. We have 3 different hunks of stuff in the numerator, and we're dividing it by one monomial. It's pretty simple. All we're doing is we're going to divide that denominator into each of these 3 things. We can even, to do this slow the first time, we could write it out like this. It's going to be 6x squared y squared over 3xy plus 3xy squared over 3xy minus 9x squared y over 3xy. Think of it as a distributive property, only it's division. We are distributing the 3xy here into all of those things because all of those things are being divided by 3xy. So each of them gets that division. From there, all we're going to do is kind of clean up each individual piece. So now we're just going to look at this one thing and make that look nice. Then we're going to look at this one. Then we're going to look at this one at a time. So for this first one, we have 6 divided by 3, which is 2. And then we have x squared on the top and an x on the bottom. So we have xx, we have x times x on the top divided by an x. So one of those x's would cancel with one of those x's, and we still have 1x on the top in the numerator. Same thing for the y's. Then we move on to the next one. We have 3 over 3, that cancels out. We have x over x, that cancels out. But we still have one more y in the numerator than we do in the denominator. So we have a y. Minus 9 divided by 3 is 3. We have x squared divided by x, which is x. And the y's cancel out. We have y over y, which is done. That's it. We did our job. That's the answer to that problem. Our goal was to divide. So we did that. We no longer have a denominator, and we did everything we could to that problem. There's really nothing else you could possibly do. You can't combine these terms. This is an xy term, this is a y term, this is an x term. They're all different. So that's that. All right. Before we take this to the next level, on several notches here, and just do just an old school elementary school division problem. Oops. So we have 8 into 9,234. Just completely made that up because it really doesn't matter. I just want you to remind you how to do long division, because right after this we're going to do long division with algebraic expressions. So long division, what we do is we start we have 8 right here, and we need to divide it into this number, and we start with this first number is a 9. So 8 divides into 9 one time, so we put a 1 here. We multiply. 1 times 8 is 8. We subtract, we get 1, and we bring down the next number and start over. Now we do 8 goes into 12. 8 goes into 12 also 1 time, so we put a 1 here. Then we multiply. 1 times 8 is 8. We subtract, we get 4. We bring down the number and we start all over again. 8 goes into 43 5 times. 5 times 8 is 40. Subtract. And then bring down the next number and start all over. 8 goes into 34 4 times. We get 32. Subtract. We're left with 2. And back when you first started doing this, back in who knows what grade, 5th grade, 4th grade, whatever it is, you would sometimes just write remainder 2. But then as you moved along in math, you realize we don't want to write remainder 2. We write 2 over whatever that original divisor was, 8. So it'd be 2 over 8. So you'd write 1,154 and 2/8. Or, better yet, 1,154 and 1/4, because 2/8 reduces to 1/4. That's about the best we can do. We could have wrote it as a decimal. We could have, there's some other things we could do, but this is going to fit the format of what we're going to do with the algebraic expressions. So, pretty good answer right there. All right, here we go. The real lesson. Those were kind of some warm-up problems, and now actual long division with algebra. So a lot of these problems, you'll see them written like this. Which is fine, but it's your job, since we're going to do long division on this, it's your job to realize that you can just write that like this. And then we're going to do this exactly like we would do this with the long division with numbers, like we just did. First thing we do is we ask ourselves, we look at this number, this not even a number, but this variable right here, and we decide what do we need to put up here so that when I multiply times this, it equals this. We're not paying attention to this part. We're not looking at any of this stuff over here. Just this and this. We're looking at those two things, and we're saying, what can I put up here times that to equal that? Here it comes. There it is. We need x. And then what's going to happen is we're now going to multiply. We're going to do x times x is x squared. Then we're going to take x times negative 6, which is negative 6x. And then we're going to subtract. When we subtract in algebra class, what we're really doing is we're changing the signs. So you'll notice right here, this was a plus. It's going to have to be a minus now because we're going to subtract. And the easiest way to do that is just to go like this. I usually put a circle around it to remind myself that I changed it. And then I'm going to put a plus here to remind myself that I changed that too. When we're subtracting an entire expression, basically what's going to happen is that minus is going to get distributed to here and to here. So you're changing these signs. And you're left with, now you have negative 1x. Negative 1x plus 6x is 5x. And what do we do next when we're doing regular old number division? We bring down the next thing. So now we're going to put down minus 30, and then we start all over. Now we're looking at this and this, and we're asking ourselves, what can we put up here times this to equal that? There it is. Positive 5 times x is 5x. 5 times negative 6 is negative 30. That came from this times this. Goes there. And then we switch the signs. So we're going to subtract, basically. So we switch this to a minus. We switch this to a plus. I don't like just putting a line through this to switch it to a plus. This shows your work a little better. Plus, it reminds you that you did actually do your switching. So this is how I've always done those problems. And you can see here we have zero remainder on this problem. because this everything cancels out. We have just 0. So the answer to this problem is x plus 5. All right, let's take it up another notch. Sometimes you'll see it written like this. So there's a problem there. And as long as there's a binomial here and not just some like n or 4n or something, if it's n plus 4 or something minus something or whatever, then we need to do long division on this problem. That's the only way to really do it. So we're going to go ahead and have to rewrite it. N plus 4 divided, and then we got that. And let's do it again. Same thing. There's really nothing too different here. We'll talk about a couple more things in detail. Number one, once again, I'm looking for something to put up here so that when I multiply by this, it equals this. And we can see we have n, we need n squared, because n squared times n equals n to the third. You'll notice I'm going to put the n squared here, not here. I just do that so everything's lined up. I have n squareds here. It'll be n squareds all the way down and all the way up here. So it just gets you organized right off the bat. So this is going to be n squared. And then n squared times n is n to the third. N squared times 4 is positive 4n. Here we go. Subtract, or in other words, switch all the signs. Of course, that always is going to make this cancel out. You're never going to have anything here. The reason you put this here was because that times that equals that. So therefore, these are the same, and when you subtract them, they are gone. So this will always be nothing here. It's all about making sure you get this part right. So that's negative 2n squared, and now it's, since the signs changed, it's negative 4n squared. Oops, it's supposed to be squared. Sorry. And so we have negative 6n squared. Which brings me to another point here. I messed up there and didn't have that squared there, which is fine. I made a mistake. It's probably worth talking about. They will always work. They will always line up. If you do everything the way I'm showing you, this stuff's always going to line up. It'll be n squared, n squared. You'll have like terms. You know, this will all make sense and flow nice. Next step, bring down the new thing and start over. You're starting over by asking yourself again, what do I put up here times n to equal negative 6n squared? We already have an n. We need the negative 6, and we need one more n. So we're going to put up here negative 6n. And then we do it. So now we multiply. Negative 6n times n is negative 6n squared. That was the whole idea. Then we have to do negative 6n times 4. Negative 6n times 4 is negative 24n. Then we switch the signs. So this becomes a plus, this becomes a plus, and there's everything just goes away. Final answer is right here. All right. All right, so here we go. Alright, so we have this problem here, and there's a couple interesting things that make this a little trickier. Well, number one is just a higher power, longer amount of stuff and all that, okay? But more importantly, and this is really going to be helpful to pay attention here, we have a fourth power that we're going to be dividing into. We have a third power, but we're missing the squared power. And if we want everything to work out nicely, when we write this out in long division, we have to fill in every little thing. We have to have a fourth, a third, a squared, an n, and a number. If we don't do that, nothing's going to line up properly. Now, instead of just saying all that, let me just show you what I mean here. We're going to write this 3n plus 1. Here comes the long division sign. And then here we go. 18n to the 4th plus 6n to the 3rd plus 0n squared plus 18n minus 3. Very, very important right there. If you don't do that, you'll have a disaster. You'll get very confused. This will keep everything flowing nicely. Don't forget that. Always look and make sure you have all the different powers covered there. Fourth, third squared, first power, no power. Other than that, I'm just going to do the same thing I've been doing here for the last couple problems. I'm going to look at this. I'm going to look at this, and I'm going to figure out what goes up here times this to equal that. We have 4 at end of the 4th here. We only have 1 here, so we're going to need 3 more, and we're going to need a 6, because 6 times 3 is 18. I mean, if you struggle with this kind of stuff, you could also just take this and divide it by that, and that's what's supposed to go up here. In this case, it's 6n to the 3rd. Then we multiply. 6n to the 3rd times 18n is 18n to the 4th. We have to continue to multiply. We want to multiply this times this to put something here, and that's 6n cubed. So we're going to write plus 6n cubed. And this one's a little bit weird. We're going to have switch signs. Don't forget to switch the signs. And we have nothing. Everything canceled out, so we have 0. And we're bringing down 0, which makes this problem even weirder. This will just cover all the weird stuff. So since we still have nothing right here, so why don't we just go ahead and bring down the next thing too. So we'll bring down 18n, because we really, here, when bringing down 0n squared right here, we didn't really bring down anything, but it's keeping everything lined up nicely. Now we're also going to need to bring down this -3 at the same time too, and the reason for that, if you think ahead here, you'll realize you're going to put a number up here. Actually, it's going to go here. You're going to put the number here times 3n to equal 18n, but you're also going to have to take that number and multiply it by 1, and you're going to have a number under here. So we always have 2 things that we're working on. Since these don't really do anything for us, we are focusing on these 2 things, and it'll make sense here when I finish it. So in other words, I'm going to put a plus 6 here, because 6 times 3n equals 18n. But 6 times 1 equals 6. And so if we hadn't brought down that -3 right now, this would just be kind of floating around in nowhere land. So we kind of always have to have 2 things going here. Then switch the signs, like so. Of course, this cancels out right here. We're left with -9. That -9 ends up being our remainder, because we don't have anything else to bring down here. We're done with the problem. So final answer to this problem is 6n cubed plus 6. And then we're not going to write remainder of -9. We're going to write minus 9 over 3n plus 1. Remember, when you're working with regular old numbers in division, whatever the remainder is, it's always that number divided by the divisor over here. We talked about that earlier. That's about as annoying as the problems get when you start having a bunch of zeros floating around in here, and then it can get a little confusing. So always just keep bringing down enough stuff so that you have the main thing that you're going to divide into. So in this case, this one we just finished, that we knew we needed to put a number up here times this to equal that. But we're also going to have to take this times this. And so we needed this other number here. So it's basically, think of it as you have two things. You have the thing you're really focused on and the thing that just kind of ends up adding or subtracting at the end to get your new your new starting point for the next round. In this case, there wasn't a next round because the problem's done. That was the remainder. This one might not be your number one focus. If you go back to the two I did before that, those are probably more of your typical homework problems. Although I'll tell you this came from the homework. This one's directly from the homework, but it's more of a weird advanced problem. All right. Hope that helps. Work hard. Be nice. See you soon.